All right, today I'll be showing you how you will be able to run your ZenML pipeline on Vertex AI using our ZenML stacks. So to get started, I'm going to be showing you a pipeline. I'll be running it on a local stack, and then we will set up all the resources on GCP, set up all the stack components for ZenML, and run the pipeline to verify that everything works. So let's get started. First off, we're going to have a look at our pipeline. The pipeline that we're going to be running with has 3 steps. The first one returns an integer, the second one returns a random number, and the third one subtracts them from one another. So the pipeline is as easy as it gets. We can now try running this pipeline, and this will be using our default stack to run the pipeline locally. So here, that's the default stack. We can also have a look at the stack to see what's in it. So the local stack consists of an artifact store, a metadata store, and an orchestrator. We'll get more into what these are when we set them up on GCP. So now that we've run it locally, let's get started on the GCP side. We're going to get started by creating a new project. We're going to be calling this the Vertex demo project. And I like to make sure that the project ID is the same as the project name. And we're good to go. This should be creating our project. And in just a few seconds, we can get right into it. So our project has been created. We can also select it as our project here now, and we can start by setting up a container registry. A container registry is responsible for storing and making available the Docker images of your code. So Vertex AI, the implementation of Vertex AI that ZenML uses is a container-based orchestrator. So that means your local code gets built into a Docker image, pushed to the container registry, and then pulled by the orchestrator so that the images can be run on the GCP side. So while it's setting up over there, we can get into registering it on the ZenML side. So we want to register it as a stack component. So we have the ZenML container registry, register. Then we need to set the name. This is going to be our GCP container registry. We're going to have to tell it that it's a GCP-based container registry, and we're going to have to tell it what the URI is. So in our case, that's eu.gcr.io. Feel free to replace the EU with US or Asia in case those regions are better for you. And then we also have to tell it the project name. So Vertex demo project. That should have worked exactly, and we can get right into the next stack component. So what we had earlier in our local stack is the artifact store. We're going to be setting up an artifact store on GCP now. For that, we will need to create a cloud bucket. This is going to be our Vertex demo bucket. And for now, it will just, okay. Somehow this bucket name has already been taken, so it's the Vertex bucket then. That's also been taken. And let's just include our project name, so Vertex demo project bucket. Okay, we finally got a bucket name that has not been taken yet. Let's head on over to our configuration. We will need the gsutil URI to register our stack component over here. So ZenML. The artifact store is responsible for storing the outputs of our steps. So all of our steps have outputs in this case. These outputs are not handed directly into the next function because the steps might be executed at completely different times. Instead, our outputs are written to the artifact store and loaded from there. The orchestrator makes sure all of this is routed correctly, And this artifact store can then be used at a later point to either access the artifacts directly or to use the artifacts as cache so that your next pipeline runs out faster. So ZenML artifact store register, then we need to give this a name as well. Let's call it the GCP artifact store. We're going to have to give this a flavor as well. The flavor will be GCP, and the path will be the one we just copied from over here. So that finishes our artifact store. Now what's left over is the metadata store, the secret manager, and the orchestrator. The secret manager will be important to store the access credentials to the metadata store. So let's do that one next. All right, so the secret manager is an API that just needs to be enabled. So we'll just have to click one button. At the same time, we can already start setting it up over here. We're going to be calling it the GCP secret manager. It's going to be a flavor GCP secrets manager. You'll have to pay attention that on the ZenML side, these things are called secret managers. GCP calls it a secret manager. Just make sure that you don't get confused by this. And the secret manager is uniquely identifiable by its project ID, as there's only one secret manager per GCP project. So to do that, we're going to head into our main dashboard and use the project number. And that should register our secret manager. As the next point, we will now head on over to the metadata store. And this is going to be a little bit more complicated. It's not called metadata store on the GCP side. It's going to be our SQL instance that we want to create. So let's jump right into it. We're choosing MySQL, unless we have an implementation for this. And we need to enable the compute engine API. Let's go ahead and do that. For the metadata store, we will need to set up a database, and we're going to have to set up all the security and connection settings for it. All of this might take a little bit of time. So the compute API has been enabled, and we can get into creating our instance. So this will be our Vertex demo DB. We'll be giving this a very easy password. I recommend you use a stronger password than this. Let's choose a region closer to us for this. So Frankfurt, I'm fine with single, and we can create it. We might have to move my face a bit, and we can create it. Again, this will take some time, so we'll be back once this is done. All right, our database instance has been created, and we can start configuring it. So first of all, we want to make sure that this is publicly accessible. For that, we're going to be enabling the public IP, and we're going to be adding a network so that everyone can access this. So we'll need to make sure that our database is available on a public IP, and we'll need to make sure that you can access it from everywhere. So I'm just calling this network everyone and setting 00 at port 0. This is going to be important so that you'll be able to access this. You can also try to make this more specific to your network. For the purpose of this demo, I'm going to leave it like this. Sorry to interrupt future Alexei here. The one thing that happened in the first recording is that my face was hiding the save button. So once you make changes to the network, make sure to click save to make sure this gets applied before heading to the security. In the security settings, you'll need to make sure that, or it is probably recommended for you to allow only SSL connections to make sure that all traffic is encrypted. So let's see. This might take a little bit of time until it takes effect. All right, we now have configured it to only allow SSL connections. The next step we'll need to do is create some client certificates and download them. So we'll download all 3 of these and we'll get back to these later on. You might want to create your own users to connect to the database. For the purpose of this demo, we'll be using the root user with the password we configured when creating this instance. On top of this, we're also going to be creating our actual database now once the database is done loading. To do this, we're going to be giving it a name. This is our demo DB. And with that, we're done configuring the MySQL database. Let's head on over to the ZenML Stack component side of things. So just like all the other ones, we're going to be registering it, giving it a name, using the flavor MySQL, and passing some of the configuration. So for one, we will need the name of the database we just created. So that's the database. It's going to be DemoDB. The host you can find in the overview here. That's going to be the host IP address. And the port is going to be the default port, so 3306. On top of that, you will need to supply the username, password, and the SSL certificates, but we don't want to do this at this point. Instead, we want to give it a secret that will be loaded at runtime from the secret manager. So that's going to be our secret, which is we're going to be calling MySQL secret. We'll get back to this later. Now that we're done with the metadata store, all that's left is our orchestrator. So let's head on over to the Vertex AI API and enable it. We can already start typing some of the things, but this is not complete yet. So that's our orchestrator that we want to register. It's going to be our GCP orchestrator. The flavor is going to be Vertex. The region is going to be this region here that is closest to us, so Europe West 3. The project is going to be the same one we used for the secret manager. That's this project number up here. Can also be found here. And finally, we're going to have to make sure that our Vertex AI workers have all the access rights to connect to the other resources. So for that, we'll head on over to our IAM and create a service account. This is going to be done over here. We're going to create the service account and give it all the roles. So this is our demo service account. Going to give it a description. We're going to give it the roles. So this will be the container registry that will need to be accessed. We will also need to give it the secret manager admin rights, and now the 2 specific Vertex. And so one is the Vertex AI custom code service, and the other one is going to be the Vertex AI service agent. So make sure all 4 of these are added And then we move on to make sure that our user has the right to deploy jobs as the service account and also has the rights to manage the service account. And with that, we've created the service account. It's this one. We will need to also pass it onto our Stack component during creation time. So that's the workflow service account here. And we can just copy paste the email from over here. With that, we forgot the flavor or maybe misspelled the flavor. Might be a space missing here. You run this. Okay, now it works. Or it doesn't. Another mistake. This is not region. This should be location. So now finally we have all our Stack components. Time to assemble them. And to do this, we're going to be, let's make this window a bit bigger for you. We're going to be creating our stack. So this is going to be our Vertex Stack. Orchestrator is going to be the TCP orchestrator. Our artifact store is going to be our, so all the components we just created, we're going to now add to our new stack. It's going to be the TCP metadata store. And our secret manager. And we need our container registry. Should be all of them. And that assembles our Vertex stack. Okay. I made another spelling mistake in here. Okay, our stack is registered. We can also set this as our default stack now. So set the Vertex stack, not set it as our default stack, but set it as our active stack. And then we can have a look at this. This is the stack that will be used now if we run a pipeline. Just as a note of warning, the first run through this will not work, but we can already verify that everything gets pushed to Vertex AI. And then on the side of Vertex AI, it will create a new service account for the workers that we can currently not see here. And once it ran through once, we will then head in here and add the relevant permissions to the new service account. So it built everything, and we can already have a look at our UI and see this in action. This might take a few minutes to provision, so we'll get back to that in a second. All right. As you can see, the pipeline failed, but not for the reason that I was predicting. I actually forgot to do something, and maybe the keen-eyed among you have already seen that I promised you we would have to still configure the secret for the metadata store, and that's exactly what we'll do right now. So to do this, we will have to register a secret within our secret manager. So ZenML secret register MySQL secret. The schema for the secret is going to be the MySQL secret, or it's going to be MySQL. And now we're going to be setting the values. So let's start with our user. The user is root. The password is going to be 1234, like we configured earlier. And now we will also have to pass in the SSL certificates. Let's start with the server certificate. Whenever you reference the file, make sure to write the @ and then followed by the file path. Let me copy paste the file paths in here. So we're going to start with the server certificate. That's here. Then we also have our SSL certificate. So that's the SSL cert, I think. Just let me make sure that's the case. Yes, SSL cert. And that's going to be at this file path. And finally, we have the SSL key, which is going to be at this file path. So key. Okay. So now this should make sure that our metadata store can be accessed from within our code. This might take a few seconds. In the meantime, we can check if our custom code service account has already been created. No. So we will have to run the pipeline again. We'll have to wait for it to fail, and then we can configure the last part of the puzzle. So Python run.py and wait for this to run so that we can see the UI, and wait for the first failure, or the second failure in our case. All right. So we're going to copy the link and paste it here to look at our pipeline. And this already looks better than before. It's actually being provisioned. So now the Docker images are provisioned to run. And at some point, this should create the new service account for our custom code for our compute engine. And that's the one we want to edit once it's created. So we have the GCP SA AI platform, this one. This is the one that we will want to change as well. So it's the GCP SA AI platform CC, stands for Vertex AI custom code. We can edit this principal and add another role. In our case, the role that we want to add here is the container registry agent. We save it. And now our custom code service agent also has the right to access the container registry. I'm not sure that this pipeline will succeed, but now we can run the pipeline again. And hopefully that's the one that's going to be running now. So let's just wait for this to run through. The Docker image is being pushed. The Vertex AI pipeline is being configured. And now we can copy the link and go into our browser to see this one. So we can now make this smaller, and we're going to have to wait for these to be provisioned and running. And as you can see, we have now completed our first two steps. The third step is running, and our pipeline runs on Vertex AI. So just to recap, by creating a MySQL database with the correct configurations on GCP, creating the correct bucket, enabling the container registry, enabling the secret manager, and enabling Vertex AI, configuring the right service manager, and setting up all these components on the ZenML side, we were able to quickly transition from our local stack to a Vertex AI hosted stack. And this should make it possible to now have your pipelines run in the cloud. We do have other options for the orchestrator, so feel free to visit our docs to find out how to do this with Kubeflow or Kubernetes. We also have a GitHub Action orchestrator and an Airflow orchestrator, so feel free to look around, see what you can change to adjust to your specific needs. And thank you so much for watching.